All right, good evening. Are we ready for today's class? Are we set for today's class? So today we are going to take a look at mathematics, and the topic is indices and logarithm. Indices and what? Logarithm. Okay, we are familiar with indices, right? We are familiar with what? Indexes. And when you talk of numbers can be represented in different ways. Am I communication? We call it what? Notation. Numbers can be presented in many ways. We call it what? In notation. Now, you are familiar with your exponential notation, right? You are familiar with that. Is your standard form. Okay, the one that is common among secondary school, at secondary school level is what? Standard form. But it's also known as what? Exponential notation. Exponential notation, or scientific notation. Now, indices. When you say that a number is in index form or is an indices, it talks about what? Raised to a power something. Am I communicating? Now, let's assume we have a number x. Let's assume we have a number x raised to power, let's say a. Am I communicating? Now this number x raised to power a is in what? Index form. Am I communicating? Now this is the indices. Is it index form? And here this x means something, and this a means what? Something too. Remember, I started with notation. This is a notation. And I told you that numbers, notation are different ways. Numbers can be what? Represented or presented. Or different way number can present itself. So we have decimal fraction is a notation too. Percentage is a notation. Standard form or exponential notation or scientific notation is also a notation. Indices, index form is also a notation. So either I call it different forms or different notation. So numbers can be represented in different forms or in different notation. Either forms or notation. I'd say that we still do percentages, fractions, and what is it called again? Standard form and what have you. But we are looking at what? Indexes. This is index form. From index. Indices came from where? Index. This is index form. When a number is raised to power a particular number. Am I communicating? So x raised to power a is in what? Index form. Now, in this form, x is the base. X is the what? Base. X is the what? Base. Why a is the power. You can call it power. You can call it index. You can call it power. You can call it index. You can also call it exponents. X what? Ponents. Exponents. X what? Ponents. So x raised to power a is the power, index or what? Exponent. Why x is the what? Base. So you can say that a number is equal to a number is said to be in index form if it appears in the form of x raised to power a, while x is the what? Base, and the a is the what? Power, index, or what? Exponents. So if you are asked to define, what do you mean by indices, or what do you mean a number being index form? You see that indexes are numbers that are expressed in form a raised to power x raised to power what? A, such that x is the what? Where x is the what? Base, and a is the what? Power, or what? Or what? Or exponent. Is it clear? Is it clear? And x is what? Base. A is what? Or what? Exponents. Now, let me know whether you are listening. Can x be a negative number? X can be a negative number. True or false? X can be a negative number. X can be a positive number too. And x can also be fraction. Can x be fraction? Can a be a negative number? A can be a negative number. Yes. At least you've seen x to the power minus what? 1. True or false? You also see half raised to the power what? Minus 1. X can also be a negative number too. Am I communicating? Good. Now, let's continue. Now, to use numbers in this form, to use indices, what are indices? What are indices? Comes, what are indices? Indices are numbers that are expressed in the form of x raised to power what? A, where x is known as the what? Base, and a is the what? Power or index or what? Exponents. Am I communicating? This is what? This is called what? And numbers in this form are called what? Indices. Am I communicating? Good. Now, let us now, having defined it, to use numbers in this form. Now, under number that you do your calculation, x times x and 1 times 1, and get your answer, right? But you cannot just follow with number in this form. There are rules. There are rules you follow to be able to do calculation using numbers in this what? Form. So this will lead us to what is called laws of what? Indices. What are laws of indices? This will lead us to laws of what? Indices. So what are laws of indices? What are the what do the laws of indices mean? These are the rules guiding the use of indices in calculation. Am I communicating? The use of indices in what? Calculation or computation using indices. Now, this rule are as follows. I'll write them out, then we'll try to do what? See if we can prove it. I hope I will not confuse you trying to prove it, but it's important you do it. You know where it came from. You know where they came from. It's very important. So laws of what? Indices. Laws of what? Indices. Laws of what? Indices. Laws of what? Indices. I'll leave them here. So as we are solving calculation, you're looking at them and tell me, if I give you a question, you tell me the one that we use it, the law that we should do what? Apply. So the first law state that if you have x raised to power a times x raised to power b, the answer is what? S raised to power a plus what? B. That's the first law of indices. Are we together? The second law states that the second, let me write this word. When I say I'm jumping, is equal to what? S raised to power what? A plus B. Then the second law, this is the law of addition. This is the product law. The second law states that A raised to the power S raised to the power A divided by X raised to the power B is equal to what? What? Minus B, good. Then the third law states that okay, let's continue. The third law states that if you have S raised to the power A bracket B, both A and B are powers, so B is not a base. Am I getting that A raised to the power A in bracket open, B bracket closes. A and B are powers. That is equal to what? A raised to the power S raised to the power A what? B. That is the what? That is the what? Sorry. That's not the law, please. The law states that if you have something like this, brackets, all raised to the power what? B, is equal to what? If you have A raised to the power B, S raised to the power A, or both S raised to the power A, S and A are in bracket, then raised to the power B, that the answer is what? S raised to the power what? A, B. Then another one, the fourth one states that S raised to the power 0 is equal to what? 1. This means that any number raised to the power 0 is what? 1. Comes raised to the power 0 is what? 1. G1 raised to the power 0 is what? 1. But me raised to the power 0 is what? All right, let's continue. That's the fourth law. The fifth law said that good. S raised to the power minus A is equal to 1 over S raised to the power A. S raised to the power minus A. S raised to the power minus A is equal to 1 over S raised to the power A. The sixth one states that X raised to the power A over B. Look up, S raised to the power A over B. Both A and B are powers, so let me write it well. S raised to the power what? Over B is equal to the sixth one states that S raised to the power A over B is equal to something like this. Please note, this is the bit root. B is not B root, as in 2 root. No, that's it. Please know that these things are not the same thing. These things are not the same thing. Please. Are they the same thing? Huh? This one is 3 root what? S. But that one is what? Cube root of what? S. Cube root of what? X. They are not the same thing. Please. This is not B root S. It's B root of what? S. So this is the cube root of S. So this one is B root of whatever it is the root of what? S. So it's not B root S. So if you have S raised to power A over B, this is what you get. Number 7. Number 7. Is there number 7? Is there number 7? Do you think that there's a rule we are missing? Check well. Do you think there's a rule we are missing? Check well. We have addition rule there, multiplication, division, index rule is there, fractional index is there, and this one. Is there anyone we are missing? Is there anyone we are missing? You don't know? Are you serious? Okay, you have not done this in class. Huh? Why? Are you serious? Why? It's okay. No problems. I just want you to understand this. Seventh rule is left for you to discover. Discover the seventh rule by yourself. For now, you stop at where? Sixth what? Law. In fact, some textbook will stop at this place. Fourth. Am I calculating? But this one, for now, we have 6. We have 6 for now. Now, let's look at the first one. How did they come about this rule that S raised to power A times S raised to power B is equal to X all raised to power A plus B? What does it mean? How did they come? How did they come to this conclusion? How did they come to this conclusion? Naturally, normally, you know. You and I know. See where they came, how they prove they got this one from. Where they got this one from. If you have, let's assume you have A raised to power 3, right? Right? Times A raised to power 4. Let's assume you have this, right? If they ask you to do this calculation, what are you going to do? You gotta start multiplying everything. True or false? You multiply A into 3, right? A times what? A, right? Times what? A, right? Right? Good. Then you also multiply this one, right? And have what? A times 4, right? A times A, 4 times, right? True or false? True or false? Now, this is 1. How many A's? 1, 2, 3, 4, 5, 6, 7. Right? So you multiply A into what? 7 times. True or false? Are you following? Who is lost? Are you following? You multiply A into what? 7 times. Which the statement is saying A is power what? 7, right? Now, take a look at this. 3 plus 4 is what? 7. So this is statement saying A is power what? 7. I said, yeah, okay, if that is the case, that means if you do S raised to power 3 times s raised to the power 4 is what? Okay, so is that so? Okay, let's call 3 what? A, right? And call 4 what? B. Is not true? If s raised to the power 3 times s raised to the power 4 is certain as saying s raised to the power what? 3 plus what? 4, which is what? S raised to the power what? 7. That means if you call 3a, it becomes s raised to the power what? A plus what? Times what? S raised to the power what? B. And you have what? S raised to the power what? A plus what? B. Is it clear? This is how they prove what? This one. This is what they did here. And came out. So to avoid, what if we are asked to multiply a raised to the power 500 times a raised to the power 600? Will you go and start doing a times a times a times a into 500? Your book will fill up now, and there will no time in exam hall. So in such case, you simply use the rule, which is simply a raised to the power 500 plus what? 600. You get a raised to the power 1000 what? 100. But I mean such rule is not there. You write it out on your book, and your book will be what? Filled up. And your book will do what? Will be what? Filled up. Now, is it confusing? If you're asked to prove this first law of indices, can you prove it? Good. Now, let's go to the second law of what? Indices. Let's prove the second law of what? Indices. Let's assume you were told no law, just you are given numbers like this to work on. You are told, I'm cleaning up. Oh. Can I? Okay, sorry. When you are done, let me know, please. When you are done, let me know, please. I don't want to clean it and get you lost. Okay, the second rule. Let's assume you were told to do this calculation. X raised to the power 10 divided by what? S raised to the power what? 4, right? So naturally, what are you going to do? You multiply out and divide by the other one, right? So naturally, you do what? S into 10, right? S times what? S times what? S, sorry. Is this S confusing you with multiplication? Should I use another alphabet? Okay, good. So you have something like this. This sentence is saying S times what? X times what? S 1, 2, 3, 4, 5, 6, 7, 8, 9 what? 10 divided by, this is S to the power 4, right? So this is what? S times what? S times what? X times what? S, right? Now, in that case, you cancel out, right? S to the power 10 is S into 10 on the numerator, divided by what? S into what? 4 in the what? Denominator. You do what? You cancel out. So S will cancel one S here. S will take care of the second X. S here will divide this S. S here will do what? Divide this S. How many S will remain? 1, 2, 3, 4, 5, 6. So we have S into 6. And X into 6 certain as said S raised to the power what? 6. So we have X 6. Look at their powers. So 10 minus 4 is what? 6. 10 minus 4 is what? 6. So if that is the case now, you simply do what? You simply do what? Say that S raised to the power what? 10 divided by what? S raised to the power what? 4. Is certain as saying S power what? 10 minus what? 4. Which is what? x to the power what? 6, right? So either is the case. You can say, okay, let this power be what? A, and let this 4 be what? B. That means that x to the power A divided by x to the power what? B is what? X to the power A minus what? B. Is it clear? Are you sure? Good. That's the second rule, second law of what? Indices. This is the second law of what? Indices. Are we ready? Any question on the proof of the second law? Any question on the proof of the second law? No question. Now let's go to the third law. Let's go to the what? Third law of what? Indices. All right. Let's assume you have x raised to the power what? 3. Are we there? Remember, we want to prove that x raised to the power A or raised to the power what? This thing means, please, this thing means x raised to the power A or raised to the power what? B. Is it clear? This is something that's saying x. Okay, you cannot expand it. Now let's go. Now let's assume you have excuse me. Okay. So let's assume you have this. Let's assume you have this. This is not saying what? Remember, this is not saying what? X times what? X raised to the power 3 is not saying what? X times what? Times what? True of us. X raised to the power 3 is not saying x times what? X. Now let's square this x raised to the power 3. Let's do what? Stand up. Walk around. Okay? I know it has not been easy since morning. You've been busy, but it's okay. Just walk around. You'll be fine. As you walk around, look up to the board. You can even be writing while you walk around. You will not sleep again. Now let's continue. This x raised to the power what? 3 is not saying x times what? X times what? X. Agreed? Now let's attempt squaring this x raised to the power 3. So that means this x to the power 3 square, right? Is that not saying x to the power 3 times what? Agreed? Do you agree with me? That x to the power 3 all square, is that not saying x to the power 3 times what? That is x raised to the power 3 into 2. True of us. So x raised to the power 3 times x raised to the power 3. Agreed? Remember our first law. Does this look like first law? So what should be the answer now? X raised to the power what? 6. Now look at this thing. What do you think you can do to this 3 and 2 to get 6? You multiply it, right? Let's do another one. If you have x raised to the power 4 into 3, x raised to the power 4 cube, right? Every x raised to the power 4 what? Cube. Is that not saying what? X to the power 4 times what? Agreed? Times what? This is not saying what's the answer? Using the first rule, first law. X to the power what? 12. What can we do to 4 and 3 to get 12? Multiply them. So if that is the case now, let us now replace this number with A and B. Let's call 4 A. It becomes what? Raised power what? A, right? Or raised power what? B. So this is certain as saying what? Raised power what? A times what? B, which is certain as saying what? S what? A B. Do you agree to this? So we have proven the what? We proved the what? I just proved the what? The third law of indices. I just proved the third law of what? Indices. If you're okay, let's go to the fourth law. All right, let's look at the fourth law. The fourth law is called the zero index. The zero index. You and I know that x raised to power 4 over s raised to power 4 is equal to what? It will cancel now, right? So this will cancel this. You get what? 1. You agree with me, right? You also agree with me that x raised to power 3 over s raised to power 3 is equal to what? 1. Now, let's apply the second law of indices here. Let's apply the second law of what? Indices here. This is division, the division law. This is division, right? If this is division, that means this is certain as saying s raised to power 3 divided by s raised to power 3. Applying the division law. Is certain as saying s raised to power 3 minus what? 3. Right? Right? Do you agree with me? Now, still maintain x. What should be the power? 0. So this is certain as what? Do you agree? Do you agree with me? So call the first 3 A and call the second 3 what? B. What implies that? Sorry, you cannot what? Just leave it at this level that s raised to power 0 is equal to what? 1. What I wanted to do doesn't follow. Please ask question. Don't keep quiet. Anything you don't understand here, please ask question. We are going to the one that are somehow that can be confusing if you don't have a foundation, a solid foundation, a basic understanding of what we've been talking about. Where I'm going to now, because I want to go to negative index and fractional index. This one is just the zero index. That's what we did now. We want to go to the next one. The fifth one is also known as negative index. Why the sixth one is also known as what? Fractional. Is known as what? Fractional index. So we want to go to the what? The negative what? Index. Negative what? Index. Any question? Any question? Any question? Ask your question. Okay, no question. Let's go to the negative what? Index. Let's go to the negative index. Let's assume you have x raised to power a times s raised to power minus what? A. Let's assume you have s raised to power a times s raised to power minus what? A. Let's apply the first rule. What will it give us? S raised to power what? A plus what? Which is certain as saying what? Okay, let me break it down well. A plus what? Minus what? A. Which is what is certain as saying what? A what? minus what? A. Who is lost? Who is lost? Are you lost? This is statement as saying what? X raised to the power what? Go back to all the rules we discussed. He said as saying what? X raised to the power what? 0. Is that as what? Mass is sweet. If you know the rule, see where we started. X raised to the power A times X raised to the power minus A is equal to what? X raised to the power A plus minus A. If you open the bracket, we have that X raised to the power A minus what? A. Which is A minus A is what? 0. Which is X raised to the power what? 0. And we are proving that X raised to the power 0 is what? 1. Do you agree with me? Do you agree with me? Good. So what does this imply? What does this imply? This implies that actually that X raised to the power A times X raised to the power minus A is equal to what? Equal to what? 1. Do you agree with me? Now, let us do some manipulations on this thing. Do you also agree with me that this is certain as saying that this is certain as saying X raised to the power A times X raised to the power minus what? A over X to the power minus, minus A. Do you agree with me? Cancel this. What will it get? Look at it well. And tell me what you notice there. Which one is similar? Okay, let me give you another instance. If you have X raised to the power A times X to the power minus A over X raised to the power what? A. Then look at this second one. X raised to the power minus A times X to the power minus A over X to the power minus A. Try breaking these two things down and tell me what you get. Are you confused? Are you confused? No, do it rough. Just do it rough. Don't write it in your note. I want to explain something. Don't write it in your. Just do it at the back of your note. I want to explain something. Break these two things down and tell me what you will get. The first one is what? 1 over X raised to the power what? A. 1 over X raised to the power A. Okay. Second one, go. All right, there's something I ask you this question now. I want to open your mind to what I want to do now. What I want to do now can be confusing. That's why I want you to come out first. Let me now see where I'm coming. Now, let me start from here. We have established that you agree with me that X raised to the power A times X to the power minus A is equal to what? 1, right? Good. If this is equal to 1, now, what of this? X to the power A times X to the power minus A over what? X to the power A. This is statement as saying what? X raised to the power what? A minus what? A. True or false? True or false? True or false? Over what? X raised to the power what? A. True, right? Statement as saying X raised to the power 0 over what? Agreed? Which is a statement as saying 1 over what? 1 over what? 1 over X raised to the power A. Now look at it. If you carry this thing, if this is 1 and this is the same thing with this one, so 1 should be here. True or false? True or false? Yes, that's what we got here. 1 over what? X raised to the power what? A. 1 over what? X raised to the power what? A. Now, remember what we are trying to prove. What are you trying to prove? That X raised to the power minus A is equal to what? 1 over what? X to the power what? Minus A. Is that what have you got to 1 over X to the power A? Look at it here. Now, how do we now link it to what? Go back to where we started. Go back to where we started. Remember that this thing is remember that we what we did here, that this times this is equal to what? X power minus, and X power 0 is equal to 1. Remember that, and we came here that this times this we arrived at this times this is equal to what? 1. Now we now resolve this and came down to this level. That this 1 over what? X to the power what? A. Now, going back to what we want to prove, X to the power what? Minus what? A. That's what we want to prove. Remember that. Now, if you come up here, if you come up here, look at this thing critically. Let me bring these two things out. Where? Let me do what? Bring these two things out. Where? We have. Therefore, we cannot prove that this. We have proved that this times this over what is equal to what? Agreed. Now, use SA to cancel the SA in the numerator. What is remaining? See what I mean? Let this cancel what? This. Can it cancel? So what is remaining? Is it clear? Is it clear? I sure you are seeing the board. Can I see the board? Look up. It seems you are assessing yourself to see the board. Can you see it now? Look at this. Okay, where did you start where did the confusion start? This one. Look at it now, it's simple. We have agreed that this is equal to what? This, right? Which means this is equal to what? This. True or false? Just cancel SA, divide this. Let's divide this. If this cancels, what's remaining? It's equal to what? What remains is S raised to the power minus A is equal to what? 1 over S raised to the power what? A. That is the what? Index rule. Is it clear? This is the what? Index what? Rule. Sorry, negative index rule, sorry. Negative index what? Law. By the time we are through with this rule, any question you see in indices, you scatter it without wasting time. That is the reason why it's good to know where some formula came from. You don't just cram it like that. Any formula you don't know where it came from, don't cram it. It doesn't make sense. This is how we lay foundation in sciences. When I was in secondary school, there's no formula you give me. I must know where the formula came from. Because without it, I will not be able to remember the formula. So if you are done, let's go to the next one. Please ask question. No. If you don't have any other question, let's go to the last. The fractional index law. The fractional index what? Law. The fractional index what? Law. Let's assume we have something like this. We call it fractional index. What if we hear negative index? What does it mean? Index is what? Index is what? Power. From when we define indices, we say that the power, when we say S raised to power A, that A is what? Power or what? Index or what? Exponent. So index is anything with the power, right? Now when you hear negative index, what do you mean that the power is what? Negative. Minus, maybe 2 raised to power minus something. It's not true. Then when you hear fraction, it means that the power is what? In fraction what? Form. That's the meaning. Now, what we are doing now is fractional index. Now let's assume we have a number like this. S raised to power half. S raised to power what? Half. Are we together? All what? Squared. S raised to power half. All squared. Which rule can we use to expand this? This. The what? Which rule? Huh? The third rule, right? Right? So this is simply what? S power what? Times what? Times what? 2, right? So 2 do what? We are left with what? X. After mainly we are left with S raised to power 1, which is certain as what? Which is certain as what? X. Good. So do you know what this means? This means that X raised to power half into 2 will give you what? X. That's the meaning. That's the what? Meaning. But you also know that root of a number times its root times that's root of a number times that same root is what? That number, right? Do you agree with me? Do you agree with me that root x times root x is what? X. Do you agree? Do you agree? Good. So that means root x what? Squared is equal to what? X. Do you agree with me? Now, if root x squared is equal to s, at the same time, s raised to power half all squared is equal to what? X. What does it mean? It means that root x all squared is equal to what? X raised to power half all squared. Do you agree with me? Do you agree with me? Do you agree with me? Are you lost? Talk. It's clear. Remember what we did? That x, we got this to be what? X. And we also should tell me now that this is what S. If this is x and this is x, that means this is equal to what? This. That's what we did here. Are we together? Where are you lost? If A is x and B is x, is A equal to B? If this is x, you agree that this is x. We did it here now, and you agreed. And you also told me that this is equal to what? X2. Oh yeah. That means this is equal to what? This one now. Look at it now. Or is it because I carry this one and put here? And this one here. Is that why I'm confused? Huh? It doesn't matter now. Okay, let me write it. So if this is this equation what? 1. I can do primary school. If this is equal to this equation 1, and this is equal to what? This equation what? 2. So if this is equal to this, and this is equal to x, and this is also equal to what? X. That means this one is equal to what? Is it clear? So that means s half s to the power half all square is equal to what? Root what? X all what? Squared. Do you agree with me? Now, if that is the case now, do you agree with me also? Do you agree with me also that if this square is equal to this square, that means this one inside is equal to this one inside? Do you agree with me? Do you agree with me? That if a square is equal to b what? Square. That means a is equal to what? B. Do you agree with me? So if s raised to the power half squared is equal to square root of x squared, that means this one is equal to what? This one. This implies that x raised to the power half is equal to what? Root s. Do you agree with me? So have you seen why? Have you ever heard anybody tell you that something raised to the power half is equal to a number raised to the power half is equal to the square root of that number? Has anybody said it to you? This is where they got it from. So that means s square is equal to what? Square root of s. Do you agree? Any number that you don't see any power on top, what is power? 1. Are you with me? Any number you cannot see the power. What is the power? So that means this is equal to this is the same as saying root s is all is power 1. Agreed? Agreed? Do you agree? Good. Do you agree? Good. Are you also aware that if you see a square root sign and there is no 2 here, there is no number here, what should be here? 2. Do you agree with me? So here is what? 2. Have you not seen that s raised to the power half is equal to this? So let's call 1 a and call 2 b. That means s raised to the power a over what? B is equal to what? What's the answer? Or what? Is it clear? Have I proven this rule? If you like, we can do this with any number. We can prove with any number we like. We get the same thing. So at this junction now, we will now go solve questions on laws of what? I promise you, unless you really understand what we just did, if you really understood what we did, there's no question you see in laws of indices you cannot answer. It's not possible. It's not possible. No matter how they twist the question, you can answer the question. It's not possible. So when you are done, you ask your question. If you are done copying the thing, you ask your question. If there is no question, we continue by solving examples and what have you. Okay, in the absence of any question, let us now start solving questions in laws of what? Indices. In laws of what? Indices. Let's solve questions in laws of what? Indices. Let's start with the simple to the complex one. All right, let's go. So what is the answer to this question? 5 raised to the power 7 times 5 raised to the power 4 is what? Fast. What's the answer? 5 raised to the power 7 times 5 raised to the power 4. 5 raised to the power. Be solving it in your question, in your notebook. Don't do it as rough. This is part of your lecture notes. Solve it in your notebook. Write the answer in your notebook. I'll give you time. You solve it. I want to give you like 1 minute for each question. 1 minute for each question. I want you to increase your speed and your accuracy, so that if you write JAM, write your WAEC, you write it well, without any issue. So I want you to increase your speed. It's very, very important. Okay. Okay. You said the answer is what? Okay, number 2. 9 raised to the power 8 divided by 9 raised to the power 5. 9 raised to the power 8 divided by 9 raised to the power 5. Huh? 9 raised to the power what? 3. What's the answer? 9 raised to the power 3. Good. The next one. 4 raised to the power 3 all raised to the power 5. Huh? 4 raised to the power 15. Good, perfect. The next one. 8 raised to the power 0 is what? 1. Okay. The next one. 6 raised to the power minus 3. Six raised to the power minus 3. Complete it. Solve it, complete it now. Complete it. One over what? 216. Okay. What's the answer, Chinwe? What's the answer, Chinwe? We are still there. Hey, what's going on? Multiply now 6 times. Okay, well, we are the big stop. 1 over what? No, tell me what you did. Which step are you taking? Let me see your step. Tell me what you did in your book. Well, 1 over, what did you do in your book? Is there? Look at which rule is that?
The 5th one.
Do it now. Is it what they are doing? Six to 1 minus 3 should be what? Minus 3 should be what? What is next to do? Look at this. What is next to do?
Is 1.
1 what?
1 over.
No, just what is the step? Write that next step you should take. Don't give me the answer. Just the next step I want to see. Is steps that give you the answer, not the answer. Stress. Tell me what you should do next. 6 minus 3 should be what? Look at the rule now. What should be the rule? Look at the rule. What is this thing we are seeing on the board?
1 over x.
1 over what?
X.
X what? So what should it be? Now, then continue solving your question. Is what? Fast. Increase your speed. What's the answer? Write the answer. That's the answer now. Good. All right, next question. 32 raised to the power 1 over 5. 32 raised to the power 1 over 5. It's simple. Just follow the rule. Simple. Remember what we did here, how we got this. Just follow the rule. Know the one that should be A and one that should be. I get your answer straight. So 32 raised to the power 1 over 2 is what? 32 raised to the power, 32 raised to the power 1 over 5. 32 raised to the power 1 over 5. 32 raised to the power what? 1 over 5. 32 raised to the power 1 over 5. What's the answer? What did you get? What is step you took? What is good is what? Perfect. So the first step is that 32 raised to the power 1 over 5 we translate if 1 is equal to A. If A is equal to 1 and B is equal to what? 5. So it is translate fifth root of what? 32. All raised to the power what? 1. Agreed. Now the answer, because of that, what is that fifth root of 32? Let me give you an example. If you hope you know that square is certain as saying second root. True or false? True or false? True or false? So asking if you hear second root of 4, see what it means. What number can you multiply 2 times to get 4? Is what? 2. Have you now see why second root or square root of 4 is what? 2. Asking cube root of 8. Cube root of 8. 3 times. What number will you multiply 3 times? And you get 8. It's 2. So that's why cube root of 8 is what? Cube root is certain as saying third root, right? Yeah. What of fifth root of what? That's 2. What number will you multiply 5 times and you get 32? Simple. You need a calculator. What number will you multiply 5 times and get 32? It's 2 now. It's not 2. It's not 2. So there is 2 raised to the power. This is now equal to what? 2 raised to the power what? 1, which is what? Which is what? Which is what? Which is what? 2. Good. It seems this one gives you a tough time. I'll give you another question on this one. Oh yeah, solve this one. Next question says, simplify 27 raised to the power 3 over 2. 27 raised to the power 3 over 2. Just do your thing. Follow the rule, then know the root it should be, and do your thing. Huh? Yes. Yes. First of all, which one is the root? Which root are you looking for? Huh? Huh? Second root. Are you sure? Check well. Is that what I said? Sorry, I mean 2/3. Forgive me. 2/3. I didn't say 3. I said 3/2. Please forgive me. 2/3. Sorry, not 3/2. The answer is what? What is the answer? Okay. What you said 3 is what? So what's the answer now? I like what you did. I like the steps you took. Wonderful. Then tell me the final answer. You got that one. What is the answer for final? What is the answer? 6. What are you saying? 3 raised to 2 is 6. 9. 9. Okay. Okay. I want to list out some assignment I want you to do. Do it so that I will see what you come up with. After this, in our next class, in our next mathematics class, we'll do something. We'll try to integrate equations, exponential equations into this logarithm, into this what is it called? Indices. Yeah. What's that? Okay, so I want to give assignments. I want to give assignment, and I want to give an assignment. An assignment. An assignment. Number 1. Or just simply simplify the following. Simple. Just simply simplify the following. The following. Number 1. 4 raised to the power minus 3 over what? 2. Number 2. 64 raised to the power 2 over 3. Number 3. 0.01 raised to the power what? 3. Number 4. 14 raised to the power 0. Don't punch calculator and answer this one. I will listen to you. Use the law of indices to solve this question. Number 5. Number 5. Two 116 raised to the power 4 over 3. 216 raised to the power 4 over 3. Number 6. 32 raised to the power 3 over 5. Number 7. 25 raised to the power 1.5. Number 8. 343 raised to the power 2 over 3. Number 9. 216 raised to the power 4 over 3. Number 10. 0.0001 raised to the power 2. So that is 10 questions. Solve these 10 questions in your answer, in your notebook. Please don't play with my assignment. We'll be writing quiz though. We'll be writing quiz here. I'll give you assignment to go and do your assignment, but we'll be writing quiz here. We'll write quiz here, so take it seriously. Any assignment I give you, do it properly. Do it in your notes. Then if you come, the when next we have mathematics, that's how we'll be looking at the assignment. So the one I give you in chemistry, when next we have chemistry, look at it. Is there even any assignment in English language? Okay, okay. It escaped my mind. Maybe in the next class. So any assignment I give you in next class of that course, we look at assignments. So in our next mathematics class, you come out here and solve this thing by yourself. I'll give you like 1 minute to solve these questions. Yes, 1 minute. No, one quick question, 1 minute to solve them. I'll see what you did. So that's how we're doing it. You go to the board, I'll sit down with you, you solve it and teach us. And when you are done, next person will go. This is how we do it. Then when it's time for quiz, I'll let you know. If I conclude on the days we write now quizzes, I'll let you know. Is it clear? Is it clear? All right. Do you have any question? Do you have any question? Do you have any question? Because we are about to end this class. So in the absence of any question, which one is that? Forest for what? Minus what? What I want to eat? Okay, I'll tell you how you solve your assignment. Go through a lot of indices. It's simple. I gave you assignments. You see, there for you to go and research on how you solve it. It's assignment I gave you. Simple. Go and look for how you research it. That's why it's assignments. This thing will keep you busy tonight. You go and walk and read tonight. Solve these questions, and in our next class, we'll look into it. Is that clear? Okay. Thank you very much. Thank you very much for today. See you next time.